All right, sorry for the delay. It's the first time I'm in this classroom. Let's get started. This is the Changing Climate ATS320. And I just want to introduce myself. My name is Andreas Schmidtner. Here's my email and phone number. My office is 256. Office hours will be Friday from 2 to 3:30. And just a couple of words. You may have noticed already I have an accent. You can guess from which country I am. Yes. Excellent. Great guess. Most people don't have more than 3 guesses to get right. But I came here about 7 years ago or so. 7, 8 years. And I studied physics in Germany. I did a PhD in Switzerland, already related to oceans and climate. And then I did a couple of postdocs in Canada and Germany, after which I came here to Corvallis, and now I'm an associate professor at the College of Earth, Oceanic, and Atmospheric Sciences. Since 2005. So I'm a planet scientist, and my specialty is I do computer modeling. So what that is essentially, writing lots of code. That may not sound very exciting, and oftentimes it is not. Looking for bugs in your code, but intellectually I find it very interesting. Because the climate science is so interdisciplinary. You need physics, which is my background, but that's not enough. You also need to know chemistry, you need to know biology, oceanography, geology. All those come together to understand the climate system, and that's what I'm trying to do. And that's what the models that we're using, the computer models, are one tool that we're using to try to understand how the climate system works, how it has changed in the past, and how it may change in the future. And I'm personally working a lot on past climate changes. We have a couple of lectures on that here too, called paleoclimate. And I think that's pretty much enough for me. The teaching assistant is June. Mariam, do you want to say a couple of words about yourself?
Sure, my name is June, and I'm teaching at the Master's in Atmospheric Science here. And I work on surface heat fluxes, mostly in the Indian Ocean. So my master's research involved going on a 3-month cruise in the Indian Ocean to collect data, which was pretty
More
cool.
exciting than computer.
But that's all I do now. I sit around and look at code, so there's a trade-off. It's good and the bad. So I will be available in BERT 324, and I put my office hours down for a couple of different hours, but I'm only going to hold 2 hours, and I was thinking I would ask you guys what you prefer. I think home would be better for the most part. So I don't know if you guys want to have office hours later in the week so that you have chances to run into problems, or what people think. No input.
So let's take Thursdays then.
Let's go with Thursday. Okay, perfect. Yeah. I'm going to come to class so I know what you guys are talking about.
All right, so you may have seen the announcement on Blackboard already. We have this incoming survey that I would like to ask you to complete. You're not graded on the answers. It doesn't matter if the answers are right or wrong. It's just to get an idea of your previous knowledge. And then we do the same thing at the end of the course and see, hopefully you learn something. And it's also, we had this same survey of previous classes, so we can kind of compare it. And you will receive credit for completing it. Now, I just also wanted to remind you on the reading assignment. I hope you all have the book. assignment for this week is chapters 1 and 2. And if you run ever into any questions, reading the textbook, bring them to class, make some notes, bring them to class, and raise them here, because it's likely that other fellow students have the same question. Okay, the lecture summaries. I think Dave already explained that to you last time, is that right? How that works? So 2 students will prepare a lecture summary for each lecture. And so the purpose of this is that your fellow students have something to go back to and read. And maybe some people have not been here, or even the people who have been here don't remember everything, so they can go back and read it. So try to put some effort in it, write real sentences, paragraphs, and not just bullet points. That's not very useful. So, and then also send this, in a Word document or ASCII, it doesn't really matter, to me, and I will kind of put those 2 summaries together into one file and then post it on Blackboard so that everybody can access. Okay? And then I will also ask those 2 to provide an oral account at the beginning of the next lecture. I've also posted the syllabus, including the course schedule, now on Blackboard, and I just wanted to go over it very quickly. So we are in week 1 here already. You've also seen the announcement about the homework, which is due on Friday, which is also when we will have the debate about human cause of climate change. So the homework is essentially reading something about this and coming up with some arguments so that we can have a lively debate on Friday. Then next week there will be a homework due on Friday. We talk more about physics and the Earth's energy budget. And then I'll also show you measurements of the observed climate changes in the last 100 years or so. And then we talk about some concepts of radiative forcing, feedback, solar, and volcanic. And then week 3, here's a holiday, and then we talk about the carbon cycle, and then start something about paleoclimate. Here are always the reading assignments, okay, textbook chapters. And if we go to week 4, we talk about paleoclimate, atmospheric circulation, lapse rate, AT climate models. And then here's another homework due. Then we'll have the midterm in week 5, and we have 1 class before that, just review of what we talked about before, and with question and answer opportunity. Then we go towards future projections, impacts. June will prepare something on extreme events. And then week 7, we talk about politics, adaptation, and mitigation. And then I guess I forgot to mention the draft term papers are due here on February 14th. And then there will be peer reviews of those, which will be due 1 week later. And then there will be 1 week of guest lectures. I will be traveling during that week. We have already Phil Moult here, who will talk about regional climate changes in the Pacific Northwest. And then the last 2 weeks will be essentially presentations of your term papers. So each of you will present for 5 minutes, 1 or 2 PowerPoint slides. But I will talk about more detail about the term papers later on. Okay, so Lisa Akers, Zoe Ash, are you prepared to give a recap of the last lecture? Who wants to start? You can stay there. Yeah, but just speak loudly so that everybody can hear.
Our lecture on Monday covered the differences between climate and weather and the importance of studying climate change. And climate determines where and how we live. Droughts can cause problems for crops and available drinking water. And knowing a region's climate averages a height of 10 kilometers and the ocean averages a depth of only 4 kilometers. The four components of the surface include the atmosphere with our air, the hydrosphere with our oceans and lakes, the cryosphere with our ice and snow, and there's a small biosphere housing us and other life forms. All of it is connected, and if any of these components change, it will affect the others. After that, we finally got around to the weather. The weather is generally localized and short-term, minutes, hours, days. Temperature, wind speed, humidity, visibility, precipitation are measured to give the instantaneous value of the atmosphere, instantaneous states of the atmosphere. And climate is the average weather over long term. Weather measurements are averaged over years or decades to give a region's climate, and averages take a long time to change, so anomalies or any change from a given reference value is easier to see when the averages are taken over large areas. In short, climate is what you expect, weather is what you get. And if you ever have the opportunity to visit Hawaii, it may be your only chance to ever see it.
Did you ever see what?
A unicorn? Or today?
I think that was a great summary. Very nice. Have you sent it to me already as a file? I guess Dave didn't mention that. Yeah. So, do you want to add something to this?
No, well, mine was just going over the four components of
Yes.
the climate system, which you went over, and then the difference between weather and climate, and then mentioning climate change. So I can read it, it'll just be repetitive.
No, that's not necessary. But if you think there's something missing, or if you had any questions, so this is also important. You know, if something is unclear for those two who are doing the summaries, that's very important because it's also likely that other fellow students didn't. It was unclear to them. So, anything, any questions that you had? Anything that was not clear?
It's pretty short. Pretty short.
Yes. Okay. So for this lecture, the summary, Haley Blanche and Sheldon Carganilla, are both of you here? Haley Blanche? No? How about Sheldon? No? Okay, we'll take the next. Zachary Carter? So, do you? Okay. This one? Okay. And Brian Cook? All right. So you will do those. Okay. So today, I will talk a little bit about the scientific method, and then what the hell is a budget, because scientists love budgets, and I'll talk about an energy budget and the Earth's energy budget, and then some physics, radiation, and that. Okay. So who knows what the scientific method is? Nobody?
Can't remember the steps, but I know what it is.
Well, yes, just tell me what you think.
Form a hypothesis.
Right? Hypothesis is involved there. And what is a hypothesis?
An educated guess.
That's right. But you have to have some topic, right? Your guess is about. So you have
Focal points. Focus.
you have right. You have a question. You have thought about some topic, and then thinking about it, you think, oh, that may work like that, and that's essentially your hypothesis. It's an idea. And then what else? What do you do with the hypothesis then? You want to test if it's true, and you want to design an experiment to test if it's true or not. And it's easier